Hello, good afternoon all. Today we are going to discuss about the second topic from surveying geomatics, that is angles and direction. In last lecture, we have discussed the overview of theodolite instrument and its earlier history, for which purposes the theodolite can be used, how theodolite have helped the civil engineers for making easy for the measurement of the various things. Okay. uh, now now we will take overview for the things. Hello. Now we will take a overview for the things which we have learned in a last topic, and in this lecture we will discuss about the some terms used in the theodolite survey and the construction part of the theodolite instrument, which is directly asked in the examination. Okay. So first of all, we will discuss for the things which have learned in the last lecture. This is a theodolite instrument which I have told in a last lecture. This is orange color theodolite instrument. It is a mechanical instrument. This is also the mechanical instrument. This is in a white color. It is shown. It is a total station or digital theodolite. In this we get the direct readings by using of the EDM, means EDM rays are used in this instrument, and it is very convenient nowadays for using for the survey. Okay, this man is green color man is shown with the total station, which is the advanced part of the this theodolite, mechanical theodolite. Okay. Now this is what the theodolite instrument is. It is a mechanical instrument. We will discuss its parts in coming points in this lecture. Okay. I will just thoroughly explain you the introduction part of this chapter. Okay. Theodolite is used for the measuring of the horizontal angles. When you have to measure the horizontal angle between two buildings or two trees or whatever you want to measure the horizontal angle on site, you will use the theodolite instrument. Okay. It is also used for the measuring of the vertical angle. Suppose you have to measure uh, height of any building, then you have to go for the measuring its height first, measuring its angle from the bottom point to the top point, so that you can get by the you can get its height by the calculations. Okay. Also theodolite can be used for the deflection angle. What is mean by deflection angle? Deflection angle means the uh, deviation angle of the anything, any ray, or you can take a river deflects by some angle, then its angle is called as a deflection angle. For measuring the deflection angle, theodolite can be used. Okay. Also theodolite can be used for the measuring of the magnetic bearing. Okay. What is mean by magnetic bearing? Magnetic bearing is the angle between the north pole of the earth and the that point, particular point. It is used for, it is taken for the location of the point on the earth. Okay. So for measuring of the magnetic bearing, theodolite is used. Theodolite can be theodolite for measuring of the magnetic bearing. The compass can be used, but compass don't have that much precise measuring. Means by using the compass we can measure angles of 10 degree, 20 degree, but for precise measuring of the any angle in 10 seconds or 20 seconds, we need to use the theodolite. What is in 1 degree there are 10 60 parts. Okay, in 1 degree there are 60 parts, which the 60 parts are called as a 1 minute. Okay, of 60 minute there is 1 degree, and for every minute there are 60 seconds. Means by 60 seconds you will get 1 minute, and by 60 minute you will get 1 degree. Okay, so you can get that much accurate reading by using the theodolite. Okay, now this is what given here in this slide also. We can measure the horizontal angle by using compass with respect to meridian. Meridian is what? Meridian is a north pole. Okay, which gives the less accurate result. Also, it is impossible to measure the vertical angle with the compass. Compass cannot be used for the vertical angle. So theodolite we need to use theodolite over there. Okay, now, so for measuring of the angle accurately for the points which are at the considerable elevation or depression or considerable distance, we need to use the theodolite. Okay, means you can measure height of any height a tower or anything by sitting at one location, fixing the theodolite and measuring the angle by using theodolite, and after some calculation you will get the height of the any building or any tower or any mountain or whatever you want. Okay, now this is finding the vertical height. Now finding the elevation difference between the various points. Suppose you have to know, does you are given 10 points at various location on earth, and you have to you have to know the elevation difference between them. You need to use the theodolite. But nowadays we don't use the theodolite. Total station instrument or GIS GPS technology is used for the knowing the elevation between the various points. Also, theodolite can be used for the ranging of the line. What is mean by ranging of the line? Ranging of the line means making the line uh, 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 extending a line. Suppose you are given 3 points, you have to extend that line beyond those 3 points. Then you will use the theodolite. Okay, means you can range that line or you can extend that line by using the theodolite. Okay, this is what we have learned in the last lecture. Now, this is the definition of theodolite survey. The survey of the system of surveying in which the angle are measured with the help of theodolite. It is called as a theodolite. If angle is measured by the help of the theodolite, then it is theodolite survey. If for measuring the angle, if you will use the compass, then it is called as compass survey. uh, Also, these are the simple definition. Just if you change the instrument, the survey get changed. Means if you for measuring a line, if you use the chain, then it will called as a chain survey. Okay, if for measuring level difference between 2 points, if you use the dumpy level, then it is level surveying. Okay, so this is the definition. What is the survey, system of surveying in which the angle are measured with the help of theodolite? Then it is called as a theodolite survey. Okay. Now, what are the types of surveying? What are the types of theodolite? Uh, Theodolite have two types according to the transiting and non-transiting of the instrument. Suppose this is the instrument, this is the telescope. Okay, if this telescope revolves, this is the horizontal angle, this is the horizontal axis, and this is the vertical axis, and this is through this is the horizontal axis. If telescope revolve around the horizontal axis, then it is called transit theodolite. Okay, if it can move up down or whatever in 360 degree or whatever, then it will called as a transit theodolite. And if this telescope doesn't revolve about this horizontal axis, then it will call non-transit theodolite. Okay, there are some theodolite of which the telescope doesn't revolve in any angle, then it will call a non-transit theodolite. Then it can be used as a dumpy level also. Okay. uh, for some non-transitive light, this telescope can be revolved for few degrees in up and down also. For 5 or 10 degree up and 5 or 10 degree down. It revolve for few degrees. Then it is also called as a non-transit theodolite. Okay, these are the two types of theodolite. What is transit theodolite and non-transit theodolite? Okay, you get by the revolution of the telescope. Okay, now another types of the theodolite according to the measuring angle system means the circle is provided on a theodolite for measuring of the angle. If that circle having the vernier scale, then it will called as a vernier theodolite. If that circle is having micrometer scale, then it will call as a micrometer scale. This is depends on the scale that is used in the theodolite. Okay, so theodolite, these are the types of the theodolite. Okay, also the naming of the theodolite is done according to the horizontal circle. So the size of the theodolite is defined according to the diameter of the main horizontal graduated circle. Suppose in a 10 centimeter theodolite, the diameter of the main graduator circle is 10 centimeter. Okay, then in 20 centimeter theodolite, the diameter of the main graduator circle will be 20 centimeter. Okay, so according to the size of the diameter of the graduated circle, the naming of the theodolite is done. Okay, uh, according to this 8 centimeter theodolite, 12 centimeter theodolite, like this various theodolites are used in a survey. Okay, now now in last lecture we have discussed the history of the theodolites, means how ancient days the theodolite was used. Okay, in ancient days how Egyptians used the instrument. It is not called as a theodolite, but on those days they were calling those instrument, the simple instrument, by the local name they have given, but they were using something strings or whatever the things that they have available for making the or building the pyramids. So earlier history also, uh, people were using the instrument, and its advanced stage is now theodolite. This is earlier history, then modern history. Okay, and then later history, which we have discussed in a last lecture. Now we will discuss some terms used in a theodolite survey. Now, if you are using a theodolite instrument for survey, then it is called as theodolite survey. If you are using compass for any survey, then it will call as compass survey. If you will chain, then it will call as chain survey. Means according to instrument, the survey get changed. So there are the some terms we will use in this chapter for the theodolite survey, which we are discussing here. These terms are directly asked in an exam. Okay, which are these terms? Centering of the theodolite instrument or transiting of the instrument. What is mean by face left? What is mean by face right? What is mean by telescope normal? What is mean by telescope inverted? Okay, or changing of the face of the instrument. Okay, changing swinging. What is mean by swinging of the telescope? We will discuss all these things. Okay, line, what is mean by line of collimination, what is mean by axis of telescope, axis of bubble tube. Okay, what is mean by vertical axis, horizontal axis. There are some adjustment which are temporary we need to do before starting of the any survey. These are the temporary adjustment. We will discuss about the temporary, what which are those temporary adjustment. Okay, then after using many times the instrument for many days, the instrument may get erroneous. Okay, then we have to remove that error by doing the permanent adjustment of the instrument. This the permanent adjustment, we don't do this permanent adjustment every time, but we have to calibrate the instrument once in a year, and while doing the calibration of the instrument, we will do the permanent adjustment. Okay, what is mean by least count of the instrument. Okay, we will discuss all these things in a over here. Okay. My voice audible?
Yes, sir.
Okay, na? Clear, na?
Ha.
Okay. See now, this is the theodolite. I have taken an image of the theodolite instrument. It is not actually theodolite. It is shown in. It is a total station, but on this place we will place the theodolite instrument. For dumpy, for leveling we will use here dumpy. For compass survey we will fix here compass. Okay. Then suppose this is a theodolite instrument. Okay, this is a tripod. Okay, on this tripod we fix the instrument. Okay, we will discuss now the terms used in a theodolite. Now first, centering. What is mean by centering? Centering means setting the theodolite exactly over instrument station so that its vertical axis lies immediately above the station mark. It can be done by means of a plumb bob suspended from the small hook attached to the vertical axis of the theodolite. Now I will say what I will show what is mean by centering over here. These are the three tripod stand. On this tripod stand, the theodolite instrument is fixed. Okay. Then for making any starting of any survey, you have to fix the theodolite instrument on the point or starting point or whatever the point you require. Okay. Then you need to fix it exactly over that point. This instrument should be exactly over that point. Okay. Then for that you have to first roughly fix this instrument, then revolve these three legs or one or two legs inward or outward or clockwise or anti-clockwise so that this theodolite instrument comes roughly on the station point. For checking the verticality of that instrumentation on the point, you will just suspend the plumb bob from the this point to the ground. What is mean by plumb bob? It is varamba in called in Marathi on site for making or checking the verticality. Okay. So we will suspend the plumb bob from here to the ground, and we will match the plumb bob bottom with the station point. Then we will get the centering of that uh, theodolite instrument. It is rough centering. Okay. Then for accurate centering, the center shifting arrangement is there. And on in this theodolite, there is some arrangement. By using that arrangement, we can move this theodolite from its original location for to and fro or clockwise or anti-clockwise. And by using this center shifting arrangement, we will easily perform this centering operation precisely. Okay. Then what is meant by centering? Centering is the fixing of the theodolite instrument exactly over the station point. Okay. For this, we will use these legs, and we will move these legs inward, outward, or clockwise or anti-clockwise, so that this theodolite will come exactly over the station point. And for checking the centering, we will use the plumb bob. Okay. Then you get the centering. Then we will come to the next point, transiting. Then this is the instrument, this is the mechanical instrument, this is the theodolite. We will discuss its parts, its various parts in the next point. Okay. Now we are discussing about the terms used in a theodolite. Okay. I will roughly tell which are these points. This is the telescope, this is the vertical circle, this is used for the measuring of the vertical angle, okay, depression or elevation angle, whatever you want, okay. This is the horizontal circle. This horizontal circle having graduations from 0 to 360 degree, 0 to 360 degree, which are used for measuring of the horizontal angle. This is the horizontal circle, okay. These are the three screws. In next part. By and the thus making it point exactly opposite direction, okay. Then if you revolve, if what is mean by transiting, uh, this is the vertical, this is a vertical axis. If you revolve this theodolite in a 180 degree, then this circle will come from left to right or right to left. Then this telescope eyepiece will go on this side, and uh, object glass will come on the another side. Then this is the simple definition of transiting. Then transiting, also known as plunging or reversing, means reversing means making this side to this side and this side to this side, okay. It is a process of turning the telescope about its horizontal axis through 180 degree, okay. If you revolve the theodolite in 180 degree in a uh, horizontal axis in its vertical plane, okay. If you revolve this in a vertical plane, means like this, you will revolve in a vertical plane about this horizontal axis. Then eyepiece will come on this side, the object glass will come on this side, vertical circle from left to come to right and right to left. Then this will called as a transiting. For what we will do the transiting, this is done because this is a mechanical instrument, okay. Then for any mechanical instrument, there are chances of error in instrumental error, okay. Means many times the line of pollination, I will tell you what is mean by line of pollination and all in next point. But just think, there are some things which get disturbed by using the theodolite. So we have to take readings by left face and right place, means by transiting, first doing the taking the measurements, and after taking one's measurement, we will transit the theodolite, and we will take another set of the measurement, and we will take average of these two sets, which will be free from the errors, okay. So for eliminating the error, we have to take two sets of the reading by doing the transiting of the theodolite, for removing the error in the instrument, okay. Then we will get the exact correct readings, okay. Now next definition: swinging of the theodolite. Swinging, it means turning the telescope about its vertical axis in a horizontal plane, okay. This is simply revolving in the horizontal plane. What is mean by swinging? Swinging is a revolving in a horizontal plane, and transiting is a revolving in a vertical plane, okay. You should get the difference in this. In transiting, you will revolve the telescope in a vertical plane, and in swinging, you will revolve the telescope in a horizontal plane, okay. Get the difference in this horizontal and vertical plane, okay. And swing is called as a right or left according to telescope is rotated in clockwise or anti-clockwise manner. Okay, means if you revolve in a horizontal plane in clockwise manner, it will call as a right swing. If you revolve this theodolite in a horizontal circle or horizontal plane in a counterclockwise manner, then it will call as a left swing. It is simple. Clockwise means right swing and anti-clockwise means left swing. Okay, then this is a swinging of theodolite. This is also we have to uh, use while making the sets of the measurement for the removing of the instrumental error in the measurement. We will just take various sets of the measurement and then take an average of this measurement to get the error less measurement. Okay, then face left. Okay, what is mean by face left? This is left. What is the position of this is called according to the position of the vertical circle. This is the vertical circle. Okay, if this vertical circle is on the left side of the theodolite, then it is called as a face left, and if this vertical circle is on the right side of this theodolite, then it will call as a face left. It is very simple. Okay, if the vertical circle of the instrument is on the left side of the observer, okay, observer, you will say observer or this telescope, okay, observer, while taking a reading, then position is called as a face left. Okay, if the vertical circle of the instrument is on the left side of the observer while taking the reading, then position is called as a face left. Okay, you get, it is very simple. And the observation are taken on a horizontal or vertical circle. In this position, it is called as a left observation. And whichever the readings are taken with the left position are called as a left face left observation. Okay, I will repeat this definition. If the vertical circle of the instrument is on the left side of the observer, or you may call as a telescope, while taking the reading, the position is called as a face left. And the observation which taken on the horizontal or vertical circle in this position, means in this left position, it is called as a face left observation. Okay, now what is mean by face right? It is simple. If you will take on left, then it is left face. If vertical circle is on right, then it will call as a face right observation. Okay, now if the vertical circle of the instrument is on the right side of the observer, the while taking the reading, the position is called as a face right. An observation taken on a horizontal or vertical circle in this position are called as a face right observation. Means uh, according to the position of this vertical circle, you will call the readings or face left or face right observation. Okay, is my voice is audible to you?
Yes, sir.
सर मधून मधून हळू येतोय मधूनच वाढतोय.
Okay, okay, sir. Okay. I will manage. Are you getting the points or not? If there is any problem, you can ask. These are the simple definitions, but if you after when we will discuss the instrument, you will get what I am telling to you. These are the just terms which we will require afterwards, but after going through this topic, you will get what I am telling to you. Okay. Then telescope normal. What is mean by telescope normal? This is also the position of the telescope or position of the bubble tube. This is telescope and there is a bubble tube fixed to this. Okay. Then if the tube is on upper side, then it is called as a telescope normal. See here, the face left position is known as telescope normal or telescope direct. Okay, means in face left position, the in this picture, the position is face right. Okay, if this would be a face left position, then you will get bubble tube over here, but this unfortunately on this in this image, this is the face right position. Okay, but if would be it would be a face left position, then you will get the bubble tube over here. Okay, then what is mean by telescope normal? The face left position is known as telescope normal because tube is on upper side. In this, bubble tube is on the bottom side. If we revolve this, if you revolve this telescope, then bubble tube goes on bottom side, and it is called as a telescope inverted. And in this picture, it is the telescope inverted, and we are discussing about telescope normal. In this, bubble is up. Okay, the face left position is known as telescope normal or telescope direct. It is telescope inverted. The face right position is known as telescope inverted. Okay, or telescope reversed, and it is also referred as a bubble down. You will get a bubble tube on bottom side. In this picture, it is a telescope inverted position. uh, the bubbles, unfortunately, the bubble tube is on other side of this vertical circle, so you can't find here. But if you see the instrument, when a bubble tube is down, it is a face right position. Okay, you will you will just watch this simple videos of this instrument. You will get how this instrument works, and where is the bubble tube and all these things, how the telescope revolves and all these things. You can just check some videos. Unfortunately, and due to COVID, we can't show you the instrument physically over here, but you can search for the videos. Various videos are available. You just go through those videos to know the construction part and how the theodolite is used. You will get very easily, and you will get user friendly with these things. Okay, now this is the telescope inverted, in which bubble is down. Now changing the phase. What is mean by changing phase? It is the operation of bringing the vertical circle to the right of the observer if it is originally to the left. Means if vertical circle is on right, and if we revolve and take it to the left, then it is called as changing the phase. Changing the phase means taking this vertical circle from left to right or right to left. It is done by the swinging. Okay, by swinging this theodolite in a horizontal plane, the phase will get changed. Means if this theodolite get revolved, the phase will get change. Then it is the operation of bringing the vertical circle to the right of the observer if it is originally to the left, and vice versa. Okay, it is done in two steps. Firstly, revolve the telescope through 180-degree in a vertical plane, and then rotate through 180-degree to the horizontal plane. How it is done? First, we have to it is done in a two step. First, we have to revolve the telescope through 180-degree. Okay, we have to revolve this theodolite in a vertical plane through 180-degree, and then rotate through 180-degree in horizontal plane. Means we have to first revolve in a vertical plane through 180-degree, and through horizontal plane in a vertical plane. Okay, then the phase would get changed. First, that is first transit the theodolite, and then swing the theodolite through 180-degree. By mistakenly here written is a 180 second. It is not 180 second, it is 180-degree. Okay, so what you have to do? First, you have to transit the theodolite. Okay, you have to transit the theodolite. What is mean by transiting? It is revolving in a vertical plane, and then rotate the theodolite or swing the theodolite in a 180-degree. What is mean by swinging? Swinging means horizontal plane. means you have to revolve in a vertical plane in 180 degree and then horizontal plane in 180 degree. Then phase will be changed of the theodolite. Okay. Now next, what is meant by line of collimation? In this diagram, we have shown what is meant by line of collimation. It is a telescope I have shown in a diagram. Okay, and that red line is a line of collimation. It is also known as the line of sight. It is an imaginary line joining the intersection of crosshairs of the diaphragm to the optical center of the object glass and its continuation. Now you will ask what is mean by crosshair, what is mean by diaphragm. Okay, what is mean by crosshair means when you will see the telescope, there is a eyepiece. Okay, on that eyepiece there are cross marks are engraved for the exact focusing of any point. These are the crosshairs. Okay, and optical center of object glass means there is an object glass on a object face. Okay, so line of collimation is known as line of sight. It is an imaginary line joining the intersection of crosshairs of the diaphragm to the optical center of the object glass and its continuation. Okay, means joining of these 2 points. These two end points is a line of collimation. Okay. Another definition, axis of telescope. Axis of telescope is also parallel to the line of collimation. Okay, it is parallel to the line of collimation. Many times it coincides with the axis of the telescope. Then what is it mean by axis of telescope? It is known as an imaginary line joining the optical center of the object glass to the optical center of the eyepiece. Okay, joining the two extreme points is a axis of the telescope. Optical center of the object glass is a towards object face and eyepiece is a towards our eyepiece. Wait a minute. If you have any doubt in between, then just ask me. Don't just listen and leave, because these are the very important terms which you would require in a next coming part of this topic. Okay, this is a very simple instrument if you get, and it is very difficult if you don't get. Okay, so just get those definition clearly, and see, watch the various videos available. Meeting will get discontinued. Rejoin after discontinuation. Rejoin the meeting.